Alright, so in this video we're going to go over reference angles. So a reference angle is defined as an acute angle. Here we're going to refer to that acute angle as alpha. There's that Greek symbol alpha. And it's made between the terminal side of theta and the x-axis. Okay. All right. So a couple things to make note here. Right, we're looking for an acute angle, the terminal side of the angle. All right. Again, we're always referring to angles in standard position unless we explicitly define it as something other than standard position. Yeah, this symbol looks weird. And the x-axis, right? Now remember, it does not distinguish between positive or negative. So simply the x-axis. So there are, in fact, four possibilities here, right? So those four possibilities look like use one, right? And those four possibilities come from our four quadrants, right? It's an acute angle, right? So if our quadrant angle was in quadrant one, right? We have terminal side there, right? If this was our angle theta, right? The acute angle here made with the x-axis would also be that same angle theta, right? So in this case, when we're dealing with quadrant one angles, the reference angle is the same as theta. Now, if we're in quadrant two of our axes, so let's say our angle was somewhere right here, right, where this was theta, right, acute angle, right, angle between 0 and 90 degrees, right, so this here would be the reference angle, right, and if we're in quadrant 3, let's say our theta was this angle here, then this angle will be our angle alpha, our reference angle. Right, and then the final possibility angle in standard position. If this was theta, then our reference angle would be that angle made with the x-axis right there. Okay, so now those are the different possibilities for the reference angle. Right now, if you notice, if we're here, this one is pretty straightforward. Right, quadrant one, easiest, theta equal to alpha. When we're in these other quadrants, right, here we, remember, always use almost like a compass, this coordinate system. Right, now if we want to find alpha here, notice all the way is pi, but that's too much. Right? So in order to find alpha, in this case we'd have pi, but we take away theta. Right? And that gets us our angle alpha, right? Our reference angle. Now over here, right, when we're in the third quadrant, right, again, use these as our guidepost here. Right. In this case, theta is bigger than pi, so when we find alpha, right, theta would be all the way, but if I take away pi, then I'm left with this angle here. Right, and for angles in the fourth quadrant, okay, so here we have, so 2 pi would be 1 full revolution here, but that's not quite, theta isn't quite 2 full revolutions. In this case, to find alpha, it would be 2 pi minus theta. Okay. All right. Now, another thing to notice here is that none of the quadrantal angles are going to have a reference angle, right? So pi over 2, there's no acute angle between pi over 2 and the x-axis. All right. So quadrantal angles do not have reference angles, right? But any other angle that does not have a terminal side on the axes, whether that be the x or the y, will have a reference angle. Okay, so now let's work out some examples here. So let's say I want to find the reference angle for 5 pi over 9. All right, now the first step I want to do is I want to sketch my angle. All right, now 5 pi over 9. Okay, so here, and again, the way I'm going to do this is I'm going to always use these as my guide. All right, so half a turn is pi, that full turn is 2 pi. So 5/9 pi. Right. One thing I know is that 5/9 pi, or 5 pi over 9, right, is bigger than pi over 2, right? And how do I know that? Well, this is half a pi. I know 5/9 is bigger than a half, right? Because 4.5 is half of 9. So this is 5. So this is definitely bigger than pi over 2. All right. And I also know it's less than pi, right? Because pi would be 9 pi over 9. Okay, so now I know that it lies in quadrant 2, right? One other thing you can do here is if you're using a calculator, or you can use your calculator here, if you just simply looked at the 5 over 9, and you can see it's a little bit more than half, but definitely less than 1. So that puts you in this area here. Okay, so, and again, this is simply a sketch. I'm not looking for anything that accurate here. It's more just kind of a visual guide, kind of helps me see how I'm going to calculate my reference angle alpha. All right, so that's 5 pi over 9. We're in quadrant 2, so we can use this kind of handy guide here. So alpha is going to be pi minus 5 pi over 9. And that becomes, getting a common denominator here, so we have 4 pi over 9. And that is our reference angle. Let me draw it here in another color here. So the reference angle here, 4 pi over 9. Okay. All right, so now let's take a look at an example here where where the angle, let's say, is bigger than 2 pi. Let's say for this example, I want to find the reference angle of 37 pi over 16. Okay. All right. So first, I want to draw this angle out. All right. Okay. All right. Now, here, this angle is larger than 2 pi. Now, how do I know that? Well, 32 over 16 that would be 2 pi, right? So I know 37 goes beyond that, right? But by how much, right? Again, a quick kind of use of my calculator to help me out. So if I just look at the fraction, 37 over 16. Now that's 2.3. Now again, what I want to focus on here is, well, when I'm drawing this out, remember 2 pi gives me 1 complete revolution, right? But now that 0.3 is less than half, right? Half would be up here, right? Pi over 2, right? So 0.3, again, we're just looking at a sketch here. That would be somewhere right here. All right, in the first quadrant is my main takeaway that I want to get from that. All right, so that would be theta. Okay, so now what I want to do is I want to find this angle here. That would be alpha. All right. Okay, so notice that here what I can do, all right, to find this alpha here, I could take my angle, the full 37 pi over 16, and then subtract 2 pi. All right. Now, how do I know I want to subtract that? Well, the full 37 pi over 16 would get us here, right? But if I take away 2 pi, right, notice the revolution I will take away that part. And that leaves me with that angle alpha right there. All right, so here, getting our common denominator, which is 16. Oops, excuse me. 32 pi over 16. All right, so we have 37 pi minus 32 pi, and we get alpha equals to 5 pi over 16. And that would be my reference angle. All right, thank you.